Okay, chapter 19 has a few different parts in it. So we're going to take a look at what I call part 2, and this is day 1 of part 2. And what we're looking at is how do we compare two means with a confidence interval. The last piece that we did, chapter 19, the first part, day 1, was how do we compare two proportions. Now we're looking at comparing two means. How do we find the difference in two means? So it's going to be similar to the proportions, but with two means. So our formula deals with the means. So the formula starts out with the difference of the two sample means. So we have two populations. We'll have two means. Whatever you call population 1, this is the mean from that one. This is the mean from population 2. Still plus minus, still the same z star from the chart. And now the standard error formula is the standard deviation of the first group squared over the sample size of the first group. The standard deviation of the second group squared over the sample size of the second group. Add them together. Big square root over everything. And that's our formula. We still have to fill in the formula. Either this information will be given to you in a problem, or again, you'll have the data. You'll run the test on the calculator, and it will give you your x bars, it'll give you your s's, it'll give you your n's, and the z star we read from the chart. So in order to make this happen, we have to identify all of these pieces. So if they give you a problem without data, you're picking these pieces out of the word problem. If they give you a problem with data, you're going to run the test on your calculator, and from the output that the calculator gives you, you still have to identify all of these pieces so you can use it into the formula. On the calculator, it's a stat test 0, which is a 2-sample t interval, stat test 0. You still have to choose data or stats. So, stat test 0, you're still going to choose either data, in which you have data in list, or you're going to choose stats because someone told you the mean and standard deviation and the sample size for one group, the mean, the standard deviation, and the sample size for another group. And the confidence level is still as a decimal. And pooling, we're going to say no to pooling. No pooling. So again, two possible inputs, whether it's data or stats. Once you run the test, you'll get an output. And again, you'll have numbers in parentheses. And from those numbers in the parentheses, we will write a conclusion. Our conclusion, though, is based on this same chart that we had last time. What do these signs tell us? So again, if both of the numbers in our parentheses are positive, then whoever population 1 is this number to this number, and with its units, higher than population 2. If they're both negative, then whoever population 2 is this number. We read this one first because the way that negative numbers are written in parentheses, this will be the lower one, to this number, higher than population 1. When we read these numbers, we disregard the negative signs. The negative's just telling us population 2. But whatever the number is, we just read the number itself from here to here, higher than whoever population 1 is. And instead of writing population 1, you actually use the words of the problem or whatever you define population 1 and 2 to be. And again, if it does have a negative and a positive, the only way you can span from negative to positive is to also cross the number 0. And since 0 is in my interval, it would suggest no difference between population 1 and 2. And that's how we're going to say that. And with all of these, we still lead out with we are whatever percent confident that, and then state this. So let's take a look at one problem in action. I want a 95% confidence interval for a difference in heart rate in beats per minute from seniors to juniors. So I asked a bunch of seniors, what's your heart rate? I asked a bunch of juniors, what's your heart rate? And I have data. Notice, the data sets are not the same size. They don't have to be. It's okay. I want a 95% confidence interval, so I know that my Z star is 1.960 from the chart. I'm going to define population 1 to be the seniors and population 2 to be the juniors. It doesn't matter, but just pick something and stick with it. I have to put all of the seniors into list 1 and all of the juniors into list 2. So I hit stat, enter. I clear out my list by going up, clear down, and I put all the seniors in here, all the juniors in here. So here's my data already entered in. Now, once the data is in, I'm going to hit stat test 0. So stat, arrow twice to test 0. And I have the data, so I have to go back and select the data. They're in list 1 and 2. Leave the frequencies alone. My confidence level is 0.95. So I am going to work my way down here to calculate. If it lets me. Hang on one second. And there's my output. So it gives me my parenthesis, but it also gives me X bar 1, X bar 2, standard deviation 1, standard deviation 2, sample size 1, sample size 2. All of that information I need to identify so I can use it in the formula. So I'm just copying all this stuff off the calculator. And then there's my general formula, and I put all my numbers in. So X bar 1, X bar 2, my Z star number of 1.960, my SX1 squared. I don't have to square it, I just write the squared symbol up there over N1, SX2 squared over N2. Fill in the formula. If I typed all this out, what would I get? I would get this in parentheses. This would be from the minus side, this is from the plus side if I typed all that into my calculator. They're both positive. What does that tell us? Whoever population 1 is this number to this number higher than population 2. Population 1 is my seniors. So I know that seniors have heart rates 5 to 10 beats per minute higher than juniors. So we are 95% confident that seniors average 5 to 10 beats per minute more than juniors, or higher than juniors. You have to state who is higher and by how many with its units. And that's a complete problem start to finish.